Today we'll start with the next topic, that is introduction to the shift registers. Okay, introduction to the shift registers.
Shift
Shift registers. Okay, what are these shift registers? We'll see. Okay, so shift registers. Uh, so shift registers are basically like there are four types of shift registers are there. One is SISO. SISO means what? Serial in, serial out. Serial in, serial out. Okay, and next you have SIPO. SIPO means serial in, parallel out. Okay, serial in, parallel out. And next you have PISO. So PISO means parallel in, serial out, serial out. And next you have PIPO. PIPO means parallel in, parallel out, parallel in, parallel out. Okay, parallel out. So basically, like SISO means what? The data will be entered serially, and data will be serially. It will go. Okay. So this is nothing but SISO. Okay. So that means shifting can be done right shift or left shift. Okay. That is nothing but SISO. And SIPO means what? SIPO means data will be entered serially, and data will be exit parallelly. Okay, data will exit parallelly. And next you have one more is that is PISO. PISO means the data will be entered parallelly, and data will be sent serially one bit. Okay, so next PIPO. PIPO means so at a time we can load the data parallelly, and at a time you can take the data parallelly. Okay, so this is CISO, and this is SIPO, and PISO, and PIPO. Is it fine? Do you understood what is this?
understood, sir.
So the shifting can be anything. It can be right shift, or it can be right shift. It can be left shift also. Okay, right shift or left shift. Is it fine?
Fine, sir.
Okay. Next, so first we'll see the CISO. That is the first one. Serial in, serial out. Okay, serial in, serial out. So mostly we are using D flip flops. Which flip flops? We are using data flip flops. Okay, delay flip flops. So these are the delay flip flops. Let us take this is D3, Q3, D2, Q2, D1, Q1, and D0 and Q0. Okay. Serial in means this is serial data. Okay. Clock is common. So it is a synchronous sequential circuit. So clock is common for all the flip flops. Clock is common for all the flip flops. And next here, so here D2 is connected, Q3 is connected to D2, Q2 is connected to D1, and Q1 is connected to
DO.
D0, and this is serial data. This is nothing but serial data out. Okay. So here what happens? First, if you write the like that is Q3, Q2, Q1, and Q0. Okay. Next, you are applying the clock. You are applying the clock. Okay.
Clock.
So initially, what happens if you are not applying any clock? The output of all flip flops will be what? Zero.
Zero.
Okay. The output of all flip flops will be zero. Okay. So let us take the output of all the flip flops will be zero. Okay. And what happens next when you are applying the second clock? Okay, the first clock, what happens if you want to load the data, this is 1111. Okay, first this will come into D3, and whatever the D3 is there, that is coming to Q3. So it becomes 1, 0, 0, 0. Okay. So now Q3 becomes 1 and the next 0, 0, 0. Okay. At second clock pulse, what happens? At second clock
Zero
pulse,
one zero zero.
again 1 will be loaded. This first this 1 will be loaded, and second
Okay.
clock pulse again
One.
this will be shifted. Okay. So that means at D2 this 1 will come. This Q2 that the 1 will come. Q3 will be loaded with this second one. Okay. So
Oh,
0, 0. Okay.
zero
So this is 1, 1, 0,
zero
0.
zero.
Okay.
So
And
the
at the
Q3 will be remain.
ah, so means a shifting operation.
Oh, okay.
Means normally this will be shifted. This will come to this side, and
Okay.
loading operation will be done. Okay. So at
Okay.
third clock pulse, what happens again? This will one will come to this D3. So whatever D3 is there, that Q3 will come, and this one will come here, and this one will come here, and next this is 0 only. So 1, 1, 0, 0.
Zero zero.
Okay, and next at fourth clock pulse, what happens? At fourth clock pulse,
D3 will be one.
D3 Q3 will be 1, Q2 will be 1, and Q1 also. Both are all are 1. No,
Yeah, all out.
all are 1. Okay, loading of data is happened. Okay, so loading of data. So that means so how many bits required to load the data? For 4
Four.
bits ISO, 4 bits. Okay, for n bits ISO, it require n bits to load the data. N bits to load the data. Okay,
Data.
data. And next again loading over. Next shifting means again I am drawing. So let us take Q3, Q2, Q1, and Q naught, and next you have clock. At fifth clock pulse, what happens? So
Uh, Q3 will be zero.
0, 1, 1,
One
1
one
shifting
one.
operation. Okay. At sixth clock pulse, 0,
Zero
0,
zero
1, 1.
one one.
At seventh clock pulse, 0, 0,
Zero
0,
zero
1.
one.
And at eighth clock pulse, what happens? All
All
the
will be zero.
all will be 0. Okay. So how many clock pulses are required to means uh, need to data out from SISO?
Eight.
8. Yeah, at 8 clock pulses, the data will be out from the fixed SISO. 8 clock pulse. If it is n bit, to n clock pulse. Okay.
N plus. Okay.
Do you understood the SISO?
Understood.
Okay. Next is SIPO.
Sheep.
SIPO means what?
Serial in parallel out.
Serial in, parallel out.
Parallel.
Parallel out. Okay. This is SIPO. Serial in parallel out. Okay. So next, I am drawing this four D flip flops. This is D3, Q3, D2, Q2, D1, Q1, D naught, Q naught.
You know.
Okay. So here serial data will be loaded. Okay. Let us take 1, 1, 1, 1. Okay. And Q3 is given to D2, Q2 is given to D1, Q1 is given to D naught. Okay. So here you are writing clock, and next Q3, Q2,
Q3, Q2, Q1, Q
Q1,
naught.
Q naught. Okay. Uh, Initially, when clock is not applied, what are the outputs of all the flip flops?
Zero.
0. Okay. So you need to give the common clock. This is synchronous sequential circuit. So by the clock only it will work. So common clock is given. So this is my clock. Okay. So all are 0 only. And first loading of data, no? At first clock pulse, what happens?
Uh, Q3 will be 1,
With Q3 we will 1, remaining all are zeros. Okay.
0.
At second clock pulse,
Q3 will be 0. 1,
1, 1, 1,
1,
0, 0.
0, 0.
Okay. At third clock pulse, what happens?
1, 1, 1, 0.
At fourth clock pulse,
All are
1,
1.
1, 1, 1. Okay. That means, so at fourth clock pulse, loading will happen. Okay. At fourth clock pulse, loading of data
Load
will happen. Okay. Loading of data will happen. Loading of data. Parallelly, you can take 4 bits of data parallel, 4 bits of data parallel. So that means you are taking out parallel. Okay. So at fourth clock pulse, you can take it will take one clock cycle. Okay. So at fourth clock cycle itself, what happens? 4 bits of data you are taking out. Okay. So uh, so here so that means at n clock pulses, the fourth clock pulse, you will getting the you are getting 4 bits of data. This is serial in parallel. Is it fine? Suppose if it is a n bit SISO, uh, uh, when you will get the data out at n clock pulses. At n clock pulses, you will get the n bit of data. Is it fine? Do you understood?
uh, so,
Here, here loading of data is happening. Okay, loading of data is happening. During this
okay.
clock period only, you are taking out the data.
Okay.
Understood? So loading at fourth clock pass, what happens? This will be loaded. So all will be one.
1.
Okay, and at fourth clock pulse itself, what you are doing? You are taking the 4 bits of data at a time, parallel out.
Oh, okay. At the time, the 4
Same
bits
time,
will be out.
yeah, at a time, that same time, that loading and taking out data happens. So at what clock pulse, the you will get the 4 bits of data
N clock
at
plus.
fourth clock pulse. Yeah, at fourth
Uh,
clock pulse. If it is n bit means n clock pulses. Do you
okay, sir.
understood?
Understood, sir.
Okay. And next you have that is the uh, third one.
PISO.
First we will see PIPO.
PIPO. Okay.
What is PIPO? Parallel in
Parallel in, parallel out.
parallel in parallel out. Okay, parallel in parallel out. Okay, so parallel out. Parallel in parallel out. If you see, so you have 4D flip flops.
4D flip flops.
4D flip flops you need to draw, and this is D3, Q3, D2, Q2, D1, Q1, D0, Q0. Okay, so here common clock is given to all the flip flops as this is synchronous sequential circuit. Register shift register is also synchronous sequential circuit. Common clock is given to all the flip flops. Okay, so this
Okay,
is
sir.
a passage of clock. You are giving the passage of clock. So this is clock, and here what you are doing means you are using one signal that is load by shift bar you are using. Okay, load by shift bar you
Shift
are
bar.
using. Shift bar, and here what you are doing means you are using one more 2 cross 1 mux. Okay, here you are using
2 cross.
2 cross 1 mux. Okay, 2 cross 1 mux. This is nothing but 2 cross 1 mux. Okay, so this D3 is given to I1. Okay, and D0 is connected to ground. Okay, and this output is given to the so here this is the line load by shift bar. Okay, load by shift bar is my line. Okay, load by shift bar is nothing but my line. So this is giving as a selection line, giving as a selection line. Okay, and this output is there, no? This output is given. So this D3 is directly given, and this one is given as a input to D3. Okay, and this Q3 is giving to uh,
T2
it is given to what 0.
or 0.
Okay, it is given to 0. It is given to 0, and D3. So here this is given to ground, and this output is given to D2. Okay, and here also it is D1 is given to 0th pin, that is I0, and I1 pin it is connected to ground, and this output is uh, this sorry, this is Q2. This is nothing but Q2. This pin is Q2. Q2 pin is given to 0 pin, and this output is given to D1, D1, and here also Q1 is given to 0th pin of this mux, 0th pin of mux. Again, this is given to ground, and this output is given to D naught, and this is Q naught, and this is Q1, Q2, and Q3. So, how many clock cycles are required to get the data out? Parallelly, you
Mm,
are loading the data. No, parallelly you are loading the data. Suppose if you want to load the data, so load should be what? Load should be one.
1.
Load should be one. Okay.
1.
So D3 and this D2. Okay, D2 also you are loading. This is coming to the D2. This is one, and this is one, and this is one. Parallelly you are loading, and parallelly you are taking out the data. How many clock cycles it requires?
Uh, 1.
One clock cycle. Yes. So number of parallelly loading and parallelly taking out the data is happening. No. So number of clock cycles required to required for data out, How many clock cycles data output is one clock cycle
1.
for PIPO. Do you understood?
Understood, sir.
Okay. So this is PIPO, and next is PISO.
PISO.
PISO means
Serial out.
parallel in serial out. Okay, so parallel in serial out also, here you are designing with 4D flip flops. You are designing with 4D flip flop. Here one more I told you, no, that signal we are using. What is that signal? That signal is
Clock.
load by shift bar.
Load. It's a
Load
load
by
by,
load by shift bar. Okay, that signal we are using. Okay,
or the one in PIPO.
in parallel in serial out we already seen, no. That
Yeah.
same signal we are using. Okay, here I am drawing. This is nothing but load by shift bar. Okay, so common clock is given to all the flip flops. So common clock is given to all the flip flops. And next, this is what is this? D3, Q3, D2, Q2, D1, Q1, D naught, Q naught. Okay, and here, so again you are using 2 cross 1 mark. Okay, so you are using 2 cross 1 mark. So 2 cross 1 marks. One input is this D3 is there. No, D3 is connected to 1 and 0 is connected to ground, and this selection line is there. No, this selection line is connected to this pin. This is nothing but load by shift bar.
Shift bar.
Load by shift bar. Okay, so that means when load by shift bar equal to let us take when load by shift bar equal to 0 means what operation it will do?
Up counter.
Load operation it will do, no?
Oh, load operation. Yes.
Load by shift bar equal to 1 means 1 second. This is shift operation. Sorry. Load by shift bar equal to 0 means it will do which operation? Active low signal, no? Shift bar. Shift bar means shift operation will be done. Okay. When load by shift bar equal to 1 means load operation will be done. Did you understand? Okay, so
Understood,
that
sir.
means there is a load signal only. Okay, and next this output is given to D3, and next here you are giving D2. This is given to 1 and this is 0, and this 0 is given from the Q2. Okay, again this is given to D2, and this selection line is there, no? This selection line is given to load by shift bar signal. Okay, again this is D1 and Q2 is given to this is 1 and this is 0, and this is given to D1. Okay,
D1 and then
and this is
selection
given,
line.
this is load by shift bar, selection line is given to load by shift bar. This is D naught
D
and
not Q1.
Q1. Yeah, so this is 1 0 and this one is given to D naught.
D not.
Okay, is it fine? So serial
Then
out,
the
serial out means here
selection
you are
line, sir.
serial underscore out,
Oh,
serial underscore out. This selection line is given to load by shift bar. All selection
okay.
lines are connected to load by shift bar only. Understood? So if you
Okay, sir.
consider this pin is one load, or you take load by shift bar also. So here clock and next outputs Q3, Q2, Q1 and
Q1,
Q
Q
naught.
not.
Okay, when clock is not given. Okay, so clock is not given means what? Clock is not given means all the outputs of flip flops equal to what? 0.
0.
Okay, first, so first clock pulse load operation will be done parallel in, no?
So all will be 1.
Yes, load by shift bar should be equal to what? 1, no?
1.
Then only load operation will be done. Do you understood? First we
Understood,
are
sir.
doing the load operation. So that means we
Okay.
are making load by shift bar equal to 1. So during first clock pulse, all ones will be loaded. Okay, you
Okay.
understood? Okay,
Understood,
and
sir.
during the second clock pulse, what happens? So you are
Shift
making load by shift bar equal to what?
0.
0. Yeah, 0 means at second clock pulse, shift operation will be done. So
All
first
will be
shift,
0.
no, no, no.
Oh,
One with shift operation will be done.
okay.
This will come here. Okay, sorry. This is one only. This is one. Okay. Yeah. This will come here. This will come here. This will come here. Whatever the vacant position is there, that is loaded with 0.
0. Oh, okay.
Okay. Third operation, third clock pulse. What happens? It becomes 0,
0
0,
and then 0, 1,
1, 1.
1.
Um, so this will be shifted. This will come here. This will come here, and this will come here. Okay. At fourth
Oh,
operation, what happens? This will go
0, 0, 0, 1.
0, 0, 0, 1. At fifth operation, at fifth clock cycle, it
All
becomes
will
0,
be
0,
0.
0, 0. All will be gone. So you are getting the data out at which one? Q naught. 1 bit
Q.
serial out. You are getting it. Your data out at Q naught. Okay. So this is about SISO, SIPO, PISO, PIPO. Do you understood? Any doubts or queries?
Understood, sir.
Understood? Okay. So one more uh, special counters are there. Okay. So special counters, those are nothing but ring counter and Johnson counter. Okay. What are those?
Ring counter and
Johnson counter.
Tom.
First, we will see ring counter. Okay, what is this ring counter? We'll see. Okay, so ring counter is nothing but uh, preset input of flip flop and clear input of flip other. So first, we are giving preset. We already seen asynchronous inputs. No,
Yes, sir. Preset and
preset
clear.
input is given to first flip flop.
First,
Okay, clear input is given to other three flip flops. Other three flip flops. Okay, so that means first flip flop is set to 1, other three flip flops are cleared to 0. No, first flip flop will set to 1, other three flip flops will, so that means first flip flop will
one,
set to 1, other three flip
other
flops will set to
zero.
zeros. So let us take the flip flop outputs are Q0, Q1, Q2 and Q3. So what is the initial state? 1, 0,
One
0,
zero
0,
zero.
0. No? Okay. So if I draw the circuit diagram, so you are using how many flip flops means 4 flip flops you
Four.
are using.
Four flip flops.
4 flip flops. Okay. So 4 flip flops I am using. So here preset, this is active low signal. This is given to first flip flop and D, okay, D naught, D naught, Q naught, okay, Q naught and D1, Q1 and D2, Q2 and D3, Q3.
Q3.
Okay, this is connected like this and this Q3 is there, no? Q3 is acting as the, you need to feedback to D naught. Okay, and common clock is given to all the flip flop, passage of clock, passage of clock, common clock is given to all the flip flops, and here clear signal is there, no? Clear signal is given. Okay, see clear signal. So clear signal is given to rest of the flip flops through this bubble pin, active low. Do you understood? Okay.
Understood,
Suppose
sir.
if I write the code, if I write the table Q naught, Q1, okay, and Q2 and Q3. Okay, this is nothing but LSB, and this one is MSB. Okay, most significant bit. So you are applying the clock pulse. Okay, initially you are applying zero. You are not applying any clock pulse. What is the initial value?
100.
100. Next, so that means this is 100. No, so this is so initially this is 100.
Zero
0.
zero.
Okay, so at second clock, at first clock pulse, what happens? This 0
One
will come
one.
to D. No,
Okay.
the 0 will come to D. So that means again this will come to this side. This will come to this side. 0 will come to this side, and 0 will come to this side. So that means that 0
Zero
will be come here, and this will be shifted. No, this will be shifted or not? One
50.
second. One second. This is one. This is what? One. One. And the remaining all are
Zero
zeros. Yeah, this will be one. And remaining all are zeros. Okay.
zero.
Okay. At second clock pass, what happens?
The one will shift it to D2.
So yeah, zero will come, no? So you will get zero,
Zero
0, 1,
one
0.
zero.
So this 1 will come here, and this 0 will come here, this 0 will come here. Okay. At third clock pulse, what happens?
One will move to
So this
D3.
side, yeah. So 0, 0, 0,
Zero
1.
one.
So this 1 will come here. Okay. So that means at second clock pulse, what happens? 0, 0, 1, 0. At third clock pulse, 0,
zero
0,
zero
0,
zero
1.
one.
Okay. At fourth clock pulse, what happens?
Uh, T3 will be 0.
Again, this 1 will come to D naught, no?
Oh, okay.
Okay. So 1 will come to D naught. That is nothing but this is Q naught only. Q naught. And again 0, 0. At fifth clock pulse, again it will repeat. So this
Oh,
one will come 0, 1,
one
0,
zero
0.
zero
At sixth clock pulse, 0, 0, 1, 0. At
zero
seventh clock
7
pulse, again it will
the
come to 0, 0, 0, 1.
0
Like this.
1.
Like this, it will be like a ring. That's why
It
we
will
call
be
it a ring
continuous.
counter. Ring counter. Do you understood the ring counter?
Understood, sir.
Okay. And next is Johnson counter. Johnson counter. So what is this Johnson counter? We'll see. Johnson counter. So Johnson counter is last flip flop complemented output is feedback as a input of first flip flop. Last flip flop complemented
Okay.
output is feedback to is feedback as an input to first flip flop. Input to first
First
flip
flip
flop.
flop.
Okay. So uh, for 3-bit Johnson counter, how many flip flops are required?
3 bit.
We need
3 flip flops.
three flip flops. Three flip flops. So mostly, which makes the mod 6 counter. So which counter is acting as a mod 6 counter means Johnson counter.
Johnson counter.
Okay. So I am drawing the 3-bit Johnson counter. This is D naught, Q naught, and next D1, Q1.
Q1.
Next you have D2, Q2.
Q.
Okay. So this is connected like this. Okay. Uh, this is what Q2 bar, no? So what I said, last flip flop complemented output is feedback as a input to the first flip flop, no? So I will take here and it is acting as a input to first flip flop. Do you understood?
Understood, sir.
Yeah. So common clock is there. Common clock is given to all the flip flop as this is synchronous sequential circuit. Common clock is given to all the flip flops. Okay, all the flip flops. So here I am writing the table clock. Okay, next Q0, Q1, and Q2.
Q.
Okay, so first you are not applying any clock. What are the outputs of flip flops?
0.
Zeros, all zeros, no? So that means output of the flip flops are all zeros only. 0, 0, 0. Okay,
0.
this is 0. This becomes what?
1.
1. At first clock pulse, what happens? This will be feedback, no? This 1 will be feedback, no?
So 0 0 1.
1, 0, 0. Why? Because this will come to D naught. Q naught equal to D naught, no?
Ah, yeah.
Okay, this one will come to D naught. Q naught equal to D naught means at first clock pulse, the output will be 1, 0,
1
0.
0 0.
Okay, at second clock pulse, what happens? Tell me.
Uh,
Again, this 1 will come, no?
Again, the Q not 1 will be
Q
remain.
naught 1 will be there. This will be shifted. So that means this 1 will come here and this is 0. So 1, 1,
1 1 0.
0. At third clock pulse, what happens?
1 1 1.
At third clock pulse, yeah. So that means here 1 will come. This 1 will be shifted and this 1 will be shifted. So that is 1, 1, 1. At fourth clock pulse,
Uh, Again, this will repeat zeros.
now all are ones means this is 1 means this becomes what? 0, no?
0.
So 0 will be feedback. Now it becomes 0,
0
1,
1
1,
1
1. At fifth clock pulse, what happens?
0 0 1
0, 0, 1.
1.
Okay. At sixth clock pulse,
All will be 0.
all will be 0. Okay. At seventh clock pulse,
1 0 0
1, 0, 0. At eighth clock pulse,
1
1, 1,
1 0.
0. Okay. So that means here at sixth clock pulse, it is coming to the initial state now.
Yeah.
At sixth clock pulse, it is coming to the initial state. So
Initial
that
state.
means we can say that Johnson counter is which counter?
Mode 6.
Mod 6 counter. So it will count from like 0 to 5 states. So if it is a, we already seen no modern counter means it will count from where to where 0 to
0 to
n
n.
minus 1. Okay. So this is nothing but it is acting as a mod 6 counter. Okay. So this is about the shift registers. One more frequency divider circuits are there that we will discuss tomorrow.
Okay, sir.
So any doubts or queries today's session?
Today's section, okay, sir. All
Okay, understood. Okay.
just I